Good morning, everyone. So we are Team Skynet, and we have chosen the theme of Blue Carbon Ecosystem. The project is Coastal Threat Alert System. So this is the name of the project, which is Blue Guard. This is the landing page, home page, about section, and this is the complete data of the landing page. Here it is. These are the different types of cards we can see here. These are the outcomes of our page. This is the dashboard and launch dashboard and the different types of features, and these are the footers. Now let's log into the page, and then we can log in with the name, Gmail ID, then the password. As we can see, that password must be at least 6 digit long. Login has failed because the user has not logged in again, so we have to try another mail ID through which the user is login, or we can authenticate with the Google also. When we will authenticate with Google, it will show us the different types of mail ID that are available within our device. Like here are two mail IDs I have, so I can directly authenticate here by using OAuth. This is the dashboard, and here we can see that we are logged in. This is the complete dashboard. This is the feature. This is the alert that we are seeing right now at this point of time, and this is the name of the station. This is the dashboard. This is the AI assistant, and this is the about page. Here we can see that the data is fetched at the real time with AI. Here it is another threat of the category algal bloom. This is the last updated time. These are the current predictions with their parameters and the level of threat. Like the probability of algal bloom to be occurred is 50.4. Then the level is very high, that means the severity of this threat is high. Now we can see that it is again medium. Now these are the recommendations that we can follow, like issue water quality warnings, swimming is to be restricted. This is about the cyclone, and this is its threat category. This is erosion, it is its threat category. Probability is 67.9%, level is high. These are other recommendations. This is the dashboard. This is real time, shows us the sea level, how much is it is increased or decreased, and there is the threshold which we can see. This is the wave height, that and it will predict that whether the wave height is high, normal, low, and etc. Here it is the wind speed, showing it kilometer per hour. Again it is the category of the speed, that whether it is high, low, or normal. This is the rainfall. This is the sea level monitoring graph, which shows us the actual and the predicted levels, and it is dynamic in nature. The sea level graph has the main purpose as is visualize the sea data, and shows us the actual measurement where the predicted values are there. These graphs are made using D3.js library, and it renders line charts with an area field. The blue lines here shows the actual value, whereas the red line shows the predicted value. Here we have used different types of gradients and animations to fill the chart, and drawing the data points for appealing appearances. Then we have also used different kinds of tooltips here, that is shows us the time and the level of the sea. All these graphs are maintained real time and with complete dynamicity. This is the prediction for the storm surge. This is the assessment, which is again AI powered, and again it is showing that the system is normal here. The percentage of storm surge at here, which is shows the risk level, is about 27%. Again, this is dynamic in nature. These are the environmental parameters. Again, this is made using d3.js library, and the main purpose of this chart is to visualize multiple types of environment parameters and their correlation among them, specifically like wave height, wind speed, and rainfall over the time. Let's see, this is the current time. These are different types of tooltips that we can see here. This is like a box plot, and it also provides us the individual view, like what about the wave height as it is in meters, the wind speed which is in kilometers per hour, the rainfall which is in so these are different types of properties, and this is like a comparative chart. Okay, so This is regarding the dashboard. Now let us understand regarding the machine learning model. So let's switch to the, so here we are with our model. Now we have imported the required libraries like logistic regression, random forest classifier, gradient boosting, standard scalar. Then we have used arima model for the time series forecasting. For saving and deploying the model we have used the joblib, and for plotting the graphs and data visualization we have used the plotly library. This is the main class which will provide all the predictions, which is coastal threat predictor. This is all the code and the decorators of the class. Here we are the loading the data, then we have to convert the timestamp to the data. Here we have matching the columns that can create the anomalies or irrelevant events which are not suitable, like cyclone threat, sea level threat, algal bloom, erosion threat. These are different types of bins and label provided to that. These are the categories which shows the severe and higher categories from low to critical. Then these are the feature columns which are present in our data set. And we are going to random values generating here for to reduce the noise and achieve the accuracy of 80 to 85%. These are the feature columns, and these are the different types of thread types. These are the train test plate where we have used the test data as 0.45, like 45% of the data. These are the different models that we are using: random forest, gradient boosting, SVM, and logistic regression. This is the best model storing, which is the best one provide the final accuracy and the ROC score. This is the ARIMA model training. These are the target columns for the ARIMA model. These are the name and call in the target dataset. This is the ADF statistics, which is related to the hypothesis, and these are the AIC. Then we have used the best parameters of the ARIMA. These are the again the feature columns that we have going to work in. Then these are the forecasts made by the ARIMA model, and this is the complete recommendations that we are going to provide when the prediction is out. These are the sorted features. Then we are plotting it. These are the plot the ARIMA forecasts which are seen on the dashboard. And then we are going to save the model. These are the code for the saving the model. And this is the accuracy warning if the accuracy goes beyond some certain values, so to prevent the overfitting or underfitting. This is all the values of important thing to cover here is that we have implemented the fast to SMS service to provide real-time live alerts and notifications like SMS push notifications to the users and the stakeholders. But to provide the full-fledged implementation it requires finances like 100 or 150 rupees sign up, so we have skipped it. Thank you very much.